Okay, 7.6 is separation of variables. It's general solutions, meaning we're not going to find the constant. Okay, over here it says recall implicit differentiation. Separation of variables is like the antiderivative format of implicit differentiation. So we're just going to do implicit differentiation real quick to remind you how we did it. If we were doing the derivative with respect to x, this would be 2x plus 2y, and then I would do dy dx, and I would say it equals a 0. I would solve for dy dx, which would be minus 2x divided by 2, negative x over y. Okay, now we kind of want to do that backwards. If we have something written like this, we want to go back and figure out what the function is. Okay, so for separation of variables, we move the common variables to the same side. We're going to integrate it, and then we're going to solve for y. Okay, so let's try it on this first one. Okay, what's step 1? It says move common variables to the same side, meaning I want the x's on the same side and the y's on the same side. Okay, I'm going to move the y's to the left and the x's to the right. Am I? No, I'm going to show a step in the middle, actually. Okay, I'm going to times this y over to this side. So I'm going to get y dy dx equals x squared. Okay, I'm going to take the integral of both sides in a second, but I actually want the dx to be with the x squared when I take the integral. So y, okay, even though dy dx is not actually a quantity or like a fraction, I'm going to treat it like a fraction. I'm going to times the dx to the other side, so I get x squared dx. Okay, I've moved the common variables to their respective sides. Okay, now I'm going to integrate. Integral. Okay, so on the left side, if I take the integral, I get y squared, and then I divide it by 2, I'll call it 1/2. And then I'm going to add a constant, and I'm going to put it equals. Okay, now on the right side, let me take the integral. I'm going to raise it to x to the third. I'm going to divide by 3, so it's 1/3. And then I want to add a constant here as well, but the constant on the left and right are not the same constant. So I'm going to call the left side one constant 1 and the one on the right side constant 2. Okay, now the third thing I want to do is I want to solve for y. Okay, now if I solve for y, I'm going to minus this constant from this constant. And I know they're both constants, so I should be able to subtract them, but I don't know what they are. Hold on, let me write. Okay, so if I do C2 minus C1, I'm going to get a new constant. I'm just going to call that a constant, normal C. There is there's many constants, but at the end they're all going to turn into a constant, so we kind of move them around a little bit. Okay, now I'm going to solve for y. I'm going to times 2. So I'm going to have y squared equals 2/3 x cubed. Now I want to times the constant by 2, but it's just a constant, and I haven't even figured out what it is yet. So 2 times c is still a constant, so I'm just leave it as c, even though it's not technically the same constant as the previous step. Now I'm going to square root both sides. When you square root, you do get a positive and a negative because it's an even root. Okay, and then this is going to be my general solution, or my y equals. And if I took the derivative of this, I should get this, but I'm not going to try. Okay, let's go ahead and try b. Okay, since this has sine x and it has the y squared, the x's and y's are kind of all mixed up, so I'm going to separate the variables, or I'm going to do separation of variables. Okay, I'm going to move the y to the left side, and the x's, I'm going to move them to the right side. So on the left side, I have dy already, so I'm going to divide by y squared. So I'm going to have 1 over y squared dy. Okay, on the right side, I already have sine x. Let me just move the dx over there. Okay, I'm going to integrate both sides. Okay, I am going to rewrite this as y to the negative 2. You don't have to. Okay, let's take the integral. Okay, so I'm going to get y to the negative 1, and I'm going to divide it by negative 1, so it's going to make it negative. Okay, and then I should add a constant like I did over here, but I'm going to add a constant on the left and the right, and I know in a second they're all going to move to the right. So I'm not going to write it on the left side, And I'm going to kind of incorporate it into the right side's constant because I know there's going to be one in a second. Okay, the integral of sine is not cosine, it's negative cosine x. Then I'm going to add a constant, and this constant is including the constant from the left and right side together, since they're going to get combined anyways. This is looking good. Let me just solve for y. Okay, I'm going to rewrite this as a fraction, I think. Negative cosine of x plus c. How do I want to solve this? I'm going to flip this upside down. So on the left side, I will have negative y, and if I do the reciprocal of the right side, I'll have 1 over. Okay, and then I'll multiply by negative. This is going to be, instead of negative cosine, it'll be positive cosine x. Now I could make this a minus c, and you're welcome to make a minus c, but since it's this random constant, when I times it by a negative, it doesn't really matter that I times it by a negative because I don't even know what it is yet. And once I find the constant, I can accommodate it. So if you have a minus there, that's fine. If you don't have a minus there, it's fine because it's at this moment, it's an unknown constant that could be anything. So the positive negative is kind of incorporated into that concept. Okay, let's try 2 more. Okay, C, dy dx equals x times y. Since there's an x and a y, I'm going to separate the variables, so I can do separation of variables. I'm going to move the y's to the left and the x's to the right. So I'm going to divide y, so it'll be 1 over y dy. And I will have x dx. Okay, I'm ready to integrate. Okay, now if I do the integral of 1 over y dy, remember I get ln of the absolute value of y. Okay, there should be a constant, but I know there's going to be a constant on the right side as well, so I'm just going to combine them into a single constant. Okay, now this is going to be x squared, and then I'm going to divide it by 2. I'm going to make it 1/2. And I'm going to add the constant on the right side rather than having it on the left and right. And customarily, you put it on the side with the x. Okay, now I need to solve for y. How do we solve for y? Okay, you can rewrite this in exponential form, which would mean that e to the this equals this, or I think some of you learned to do e to the something. I'm going to write out that step, although I probably won't in the future. So if I do e to this, it kind of cancels out the e to the e and the ln, which means I'm also doing e to the this. Okay, the e and the ln kind of cancel out, so I'm left with the absolute value of y equals this thing. Okay, now that thing over there, there's nothing really wrong with this thing except for almost, 99% of the time they simplify that. So let me simplify that and then I'll finish solving this. Okay, according to the exponent rules, let me write this down here. E to the 1/2 x squared plus c is the same as e to the 1/2 x squared times e to the c. Because these have the same base, I would add their exponents and I would end up with this expression. Okay, now let's look at this again. Now, e to the c is some kind of constant because c is a constant and e is a constant. So rather than writing e to the c as e to the c, they're just going to give it another name as a constant. So e to the c is some kind of constant, so they call it some kind of constant. Let's make it a c. They put it in the front and then they'll write it like this. Okay, now I'm going to do one more step that is going to get not used in a second, so I'm going to write in orange. Okay, so now if you do the absolute value of y equals some number like 2, technically the answer is 2 or negative 2. Because when I absolute value 2 and I absolute value negative 2, I get a positive 2. Okay, which means technically y equals plus or minus ce to the 1/2 of x squared. Okay, now the thing about this though is because it has this weird c here, and c is this arbitrary constant which we don't even know what it is. We haven't assigned it a value, and it could already be positive or negative. So you don't need to say it's positive or negative because we don't even know what it is, which is why we often just make it c e to the 1/2 x squared, because the plus minus just isn't necessary when I'm dealing with an arbitrary constant. And it's because it's being multiplied by the c. Okay, one more. Let's try D. Okay, D. We have dy dx equals 2xy plus 4x. I need to separate the variables because there's too many x's and y's. Can they be separated right now? See, right now if I move the 4x over, I'm still going to be stuck with this x, so I'm going to have to factor something out. What can I factor out? I could take out the x for sure. I think I'll take out the 2x. Y plus 2x times 2. 2xy plus 4x, that works. Okay, now I can separate it. I'll divide the y plus 2 to the left side. And then I'll have the 2x and the dx on the right side. Okay, let me go ahead and integrate. Okay, since it's 1 over y plus 2, I'm thinking ln. Okay, so I'm going to do the ln of the absolute value of y plus 2. Okay, technically I could use u substitution here. I would pick my u to be y plus 2, but since the derivative of u would just be 1, it's not really going to mess this up, so I'm just going to leave it as it is. Okay, there should be a constant, but I'm going to incorporate the constant on the right side. Okay, if I take the antiderivative, 2x squared divided by 2 goes down to x squared. I'm going to put my constant here. Okay, let's keep going. Okay, I'm going to do e to the something. So I have the absolute value of y plus 2 equals e to the x squared plus c. We're still okay? Okay, now they're going to do the same thing we did here. This is really e to the x squared times e to the c. And I'm not going to show this step, but this is e to the x squared times e to the c. And because e to the c is that weird, it's going to be a constant anyways, and we haven't figured out what the constant is anyways, we're going to change this to c e to the x squared. Okay, now I have this absolute value of y plus 2. It has to equal, this has to be positive, which it is, but y plus 2 could be a positive or a negative. But because of this random constant in the front, putting a plus or minus here is redundant, or it's just unnecessary. So I'm going to say y plus 2 equals this. And the c is like absorbing the plus minus situation. Okay, let me subtract the 2. Okay, and then this is y equals c e to the x squared, and then minus 2.